Hello, welcome everyone. Thank you for joining us for today's Preservation School, the restoration of the Flatiron Building. Some upcoming program we have includes Preservation School classes on the restoration of the Roosevelt Island Lighthouse on April 23rd and on restoration of block printed wallpaper on April 29th. Also on April 29th, we have our Six Celebrate launch party, and we have a Six Celebrate scavenger hunt with Urban Archive coming up for downtown Brooklyn on April 26th. You can find out more information about all of those and other programming on our website, hdc.org. Tonight's class is being recorded and will be posted to our YouTube channel for free viewing. You may also watch all of our previous Preservation School classes, virtual tours, and conference panels, including the 2025 conference that we just had is now available. I would like to thank the New York City Department of Cultural Affairs, City Council, and the New York State Council of the Arts for supporting Preservation School. If you have any questions, you can add them to the chat and they'll be addressed at the end. And now I'll hand it over to Alexei to lead today's class. Thank you.
Great. Thank you, Michelle, and thank you to the Historic Council for having us today to talk about our work that has been ongoing at the Flatiron Building. So my name is Alexei Tajzler. I'm a registered architect in New York and New Jersey. I'm also a qualified exterior wall inspector, also known as a QE, and I'm a director at HLZAE. I've been with the firm for 17 years now and still ticking. So quick word about the firm. It's a full-service architectural and engineering firm. We specialize in exterior and interior restoration, preservation, and alteration of existing buildings and their systems. We have architects, engineers, technical building system specialists. We do exterior envelope, MEP, fire protection system upgrades, and even forensic investigation for newer buildings. We've been in business for 40 years, and we like to think we've developed an excellent reputation as the go-to architect and engineering firm for existing residential, commercial, and institutional properties here in New York. We are an architect's architect, and we take the view that expert restoration is essential not only to the environmental sustainability, but also the financial sustainability of each property. So enough about our firm. I'm going to dive right into the Flatiron Building. So I'm sure many of you know it was completed in 1902, and it's now become an iconic symbol of New York City's architectural landscape. It's renowned for its distinctive triangular shape, and when it was first built, it was one of the tallest buildings in the city, which has, of course, quickly been surpassed by other buildings not too long afterwards. It did have a lot of initial skepticism about its stability. A lot of people thought it was going to fall down when they first built it, but it clearly has not, and it stood the test of time. It continues to be a celebrated landmark in the heart of Manhattan. Fun fact, it was originally called the Fuller Building. The Fuller Company paid to build the building. It was their headquarters, but New York Herald coined the term Flatiron Building, and it was just too good to ignore. So everyone called it the Flatiron Building, and now we have a whole district, historic district, named after the Flatiron Building. And eventually, Fuller sold the building in 1925. It was then designated New York City landmark 1 year after the law was passed in 1965. So quick little locations. I'm sure you all know where this is, but just in case you don't, it's 175 Fifth Avenue. It's between 22nd and 23rd Street in Manhattan. The architect was Daniel H. Burnham, well known for his work in Chicago, but was originally from New York. It's 290 feet tall, it's 21 stories plus a penthouse, and across the 3 street facades, it's 460 linear feet in total. So I'll walk you up the building from the ground floor and kind of talk about the materials. First 3 floors are a limestone plinth course, which then give way to terracotta. There is an extensive amount of terracotta ornamentation on this building. It's in the form of lintels, sills, jambs, medallions, spandrels, keystones, and water tables. And you can see the terracotta here. In addition, the Flatiron Building does have quite a lot of brick. Most people don't think of the Flatiron Building as kind of a brick building. It really doesn't read as a brick building from the street. It reads as a stone building or a terracotta building, and that was the intention of the original architects. Terracotta was actually created to mimic hand-carved stone. Basically, when America was exploding with construction, we needed to build buildings fast, and we wanted them to look nice. And in lieu of going to a quarry and pulling, acres of limestone like they do in Paris. They went with terracotta, and terracotta mimicked the look of stone. And in addition, even when you get further up the building, they did the same with brick. So brick is pretend to look like terracotta, and the terracotta is pretend to look like stone. Sorry, my mouse wheel keeps skipping. Once you get to the 17th floor, though, it does go back to 100% terracotta, and that terracotta does run up to the 21st floor, which has the cornice. And at the very tip of the building, we have a GFRC brick pier and balustrade combination. And then we also have a stucco penthouse, which you can kind of see here with my cursor. And then throughout the entire facade is aluminum frame double hung windows. So again, starting from the bottom, we have limestone giving away to terracotta, then terracotta and brick, and then back to fully terracotta, and then finishing with GFRC and stucco. So a wealth of materials is present on this building. So like I said, in 1966, 1 year after LP Landmark Preservation Commission was formed, it became a designated historic building. They found that it had special character, special historic and aesthetical interest, and value as part of the development, heritage, and cultural characteristics of New York City. They said that, among its important qualities, it's an interesting example of early steel frame skyscraper built on an unusual triangular site that, due to its prow-like effect and its northern end, creates an impression of great slenderness and height that displays a wealth of ornamental detail representative of the time. And although utilitarian office building, I love that line, a little bit of a slight, right? It has inspired outpourings of almost a poetic quality. So here's a picture of it in the back. This was a giant arch that they built, I believe, to celebrate Spanish-American War or World War I. But it was made out of plaster, and it was torn down a few years later because the city could not agree on who was to pay for it. Quite a shame, though. So the building itself, for over 120 years, it's been an office building. The early tenants were the Equitable Life Insurance Society and the Imperial Russian Consulate, so it really dates the building there. In 1945, it was valued at $1.05 million. It's managed by Hemsley Spear. Major tenant at this point was Macmillan Publishers, who were there up until 2019. In 1991, a restoration program was undertaken, and in 1997, Newmark and Company bought out Hemsley and did even further upgrades and improvements. Fast forward to 2023, building went to a very public auction. I'm sure many of you read it in the papers, and it ultimately sold for $161 million, owned in partnership with GFP, Brodsky, and Sorgente, and then the plans are now to convert it to residences. So you can see this is one of the offices in the north. It's on the very covered northern end, and there is a terrace on that floor. So why are we here fixing the building? The reason is FISP. Some of you may know it used to be called Local Law 11/98. It's also before that it was called Local Law 10 of 1980. But what it requires is owners of buildings greater than 6 stories must inspect their exterior walls and appurtenances periodically. The new code requires it to be done every 60 feet of a public-facing facade under the purview of a qualified exterior wall inspector, or QE. You then have to file an acceptable report with the New York City DOB every 5 years, and that has been going on every 5 years since the 80s. We are now in cycle 10 of that, so it continues every 5 years. For the Flatiron, in 2018, it was inspected. For cycle 8, again, we're now in cycle 10. In cycle 8, it was inspected, and it was determined to be unsafe, which is the most severe category for facade inspections, requiring an immediate sidewalk shed and paving the way for the restoration program. So we have the inspection done. Now, what do we do next? We go into developing and implementing the scope. So the first thing we start with is that facade report. And you can actually see in this picture, there is a rope access inspector doing one of those close-up inspections. Those close-up inspections can be done via rope access. They can also be done from a boom or most commonly a window washer style suspended scaffold. The FIS report found the following: cracks and spalls in the terracotta limestone and the GFRC, and spalls in the brick masonry. So again, all the materials that I talked about to begin with, each one of those had issues that required the building to be called unsafe. And then they were failed or failing previous patches. As I mentioned before, in 1991, there was work done to the facade. There was certainly work done to the facade before that. It is 120 years old, so that's not uncommon. So development scope, we want to focus on the terracotta primarily. And so I just want to explain a little bit about what exactly is architectural terracotta. It comes from the Italian terra, earth, and cotta meaning baked. Terracotta, as I'm sure you've all made clay pots in pottery class or camp, right? It's been around for a very long time. It was used for construction, though, by the ancient Greeks, the Egyptians, the Romans, the Chinese, Indus Valley, and Native American cultures. But modern usage for facade cladding came into fashion in the late 19th century after the Great Chicago Fire in 1871. It was a devastating fire. A good portion of the city was completely destroyed, and they wanted to rebuild. And originally, it was looked at as a good fireproofing material, and it's still very commonly found where you have terracotta tiles around steel structures in New York City and Chicago and other cities. But the architects liked it, including Dana Burnham, because it had the characteristics that it was lightweight, it was moldable, you could mass produce it, and had the ability to mimic costlier natural stones, whether that's limestone, marble, or granite. Again, instead of having these tradesmen from the old world, you could just make molds in the new world and quickly ship them and install them into facades. So why does it fail and why do we always hear about it? Well, the sad truth is it's actually really not the terracotta's fault. If you took that same clay pot in pottery class and you put it in your backyard, and you've returned 10, 15, 20 years later, it would probably still be there and probably be in very similar shape. The issue is that terracotta needs structural support to be installed and stay on buildings. And that is commonly done with iron or steel systems. And at the time of the turn of the century, really up until the 1950s, we weren't really waterproofing our buildings. We were just putting in steel. Maybe we were painting the steel at best, and that was it. And so when iron or steel rusts, its members concurrently expand and weaken. The expansion is called rust jacking. And what happens is that the steel or iron, which is much stronger than the terracotta, gets larger and it starts to push on the terracotta. And after many, many freeze-thaw cycles, which we have in New York City all the time, it continues to be a problem to the point where eventually you get a crack, little hairline crack, and then water gets in, freezes, that hairline crack gets bigger and bigger and bigger, and then ultimately you have spalls that land, fall off the facade and land on the street or on the other building services before, and then now we're into a public safety issue, which brings us back to FISP. So here are just some early photographs from the initial inspections. You can actually see the rope for the rope access inspectors in some of these photographs. You can see here, this is up at the very top of the building, this is the cornice. We are always nervous about these types of cracks because the fear is that these cracks, as they grow, the triangles meet each other, and then you ultimately get spalls of a corner of a piece to fall. Here is a previous crack that was done probably in the early 90s that is returning. Here we have patches that have spalled out. This is the foot of the inspector. There is nothing between the foot and the street in this photograph. Here you can see stones, very highly ornamental stones, and kind of more plainer stones here on the returns. Both have been patched many, many times before and are starting to crack again. And then at the brick, you have spalled brick masonry. Brick is a wonderful product, always has been. The issue is that the mortar joints are porous, and once the water gets through the joints, they can sometimes be trapped and cause the brick face to spall. You most commonly see this on white brick buildings that were built in the city in the 40s, 50s, 60s, 70s that are glazed and are even worse. And if you look at a lot of white brick buildings in the city, you will see a lot of brick repair being done continuously, also due to FISP. And then here at the base, this is part of the limestone. You can see there are some metal anchors that were originally installed for awnings, for sunshades. They were left in place. And if you leave a piece of steel in a facade long enough, it will rust. And as it rusts, you can see a perfect example here, it will cause the surrounding masonry to crack. And that will only continue until they are addressed. Some other previous patches, crack repairs that were done. some steel supports that were added. This is kind of a smear coat to try to mimic the stone that was there. Not the best looking one. Again, it's the facade. The Flatiron Building was just full of examples of this over and over again. Previous repair is done, and then another crack appears. Previous now you can kind of where to fall. It would fall a couple hundred feet onto the street, which is something that none of us want. And then at the very top of the building, we have the GFRC, which is also starting to show some cracks and some spalls as well. So we have all these photographs, all these inspections. Now we have to move into actually developing the scope to the point where we can file with the city and bid it out to a contractor. In the industry, we call these construction documents, or most commonly CDs. They set forth requirements of the project. They include specifications and drawings that establish quality levels for the materials and systems. We also created the bid breakdown, which is 50 independent line items over 134 pages. Our scope had no work on the windows or the storefront, though those are also being done by another consultant. Once we had the CDs done, we had to file the projects with both LPC and DOB. We competitively bid it out to a list of qualified general contractors that work in the exterior restoration sphere, and ultimately AWR Group was awarded the project in spring of 2019. So now we have a contractor on board. We can really start mobilization. And that first step is to put pipe scaffolding. Again, everything before this was just done by rope access every 60 feet or a few little spots here. Now that we have pipe scaffolding plus some suspended scaffolding, we're actually able to look at every square inch of the building and really get an understanding of what is going on. Our bids are built with allowances based off of our best guess and estimates with some contingency, but nothing replaces actually being on a building and being able to look at every square inch. So in order for us to keep track of that, we had to divide the building into a grid of individual facades, which I will get to on the next slide. And that this task involved 15 employees across HLZAE, which had architectural, structural, and special inspectors. And then we also had developed an on-site field office, which was in conjunction with the general contractor, AWR, and Gladdy McBean, who was the terracotta vendor. So here's the grid. The building was split into 400 individually focused areas of about 12 by 30 feet. This allows us to kind of keep track of everything, not kind of, but actually legitimately keep track of everything, and be able to kind of see the trees and the forest, and then see the forest and then the trees back and forth, allowed us to track everything. And we have tablets that we're in the field. We mark a certain area that needs a tag, whether that's crack repair, unit replacement, sealant replacement, etc. And that is geo-tracked in software called PlanGrid, which is connected to the cloud so that we can look at it anytime at home, in the office, back in the field with contractors, with the client, etc. As of today, we have 9,501 individual tags of some type of repair, and that includes nearly 3,200 individual terracotta units being replaced, 25,000 linear feet of masonry joints being repointed, and 20,000 linear feet of crack repair, among many other items. So here's the pipe scaffolding. You can see this is along Fifth Avenue. You can see the kind of the conditions that the inspectors and workers kind of have to deal with. I always joke that this is an adult jungle gym. At the end of the day, stepping over these things starts to get a little hard on the legs and back, but you know, this is the reality that we have to deal with. Other facades, we utilize suspended scaffolding. In the industry, we call these drops. You can see Ralph from my office is actually inspecting, and just to test him out, I gave him a phone call and then I took a picture of him, and to his credit, he did not send me a voicemail. He did answer the call, so good for Rob. Now, while we're on the building and while we can finally look at everything, we're able to do sounding. Sounding is commonly done with this either ceramic or rubber mallet, and we actually hit the stones with human force, and we try to register back what do we hear in comparison to other stones. It gives us an extra layer of knowledge and information that's beyond just the superficial, it has a crack. Sometimes the stones even shift, which lets us know the stone is unstable and that the steel or iron straps behind is a real problem. And in other areas, we're able to do very large probes. This is up at the cornice. Even for the Flatiron Building, we have some historical photographs, sorry, drawings, but we don't have all of them. It's very uncommon to actually have the original drawings of most buildings in New York City that we work on. Even if you do have all of them, this is a 120-year-old building, and as I mentioned before, it's gone through restoration programs before us. We don't have those drawings either. So a lot of times you kind of have to do exploratory probes and find out things in real time. What is exactly going on? What was done before? Why is this failing? Why is this leaking? And that's all part of the process once we have pipe scaffolding up that we can safely open very large areas without fear to the public. Up at the very roof, the pipe scaffolding stops. So this is outside of the balustrades. We have to tie back with a lanyard. And then again, the pipe scaffolding is great, but you get a workout having to inspect this building. Crawling on your hands and knees is not that uncommon, sadly. So going back to terracotta, in a typical building that's historic, LPC passed rules that anything above the 6th floor, you can actually use replacement materials. And those are most commonly architectural precast, glass fiber reinforced concrete, which is called GFRC, or fiberglass. This is in part because there are only 2 vendors domestically, Boston Valley up near Buffalo, New York, and Gladdy McBean, which is near Sacramento in California. They are the only 2 vendors domestically that can produce architectural terracotta that have the trade knowledge and the capabilities. So despite the fact that the Flatiron Building does have terracotta above the 6th floor, LPC still mandated that all unit replacement needed to be done in terracotta. We were not permitted to use replica materials, given the special architectural and historic character of the building. So, it's sometimes a little bit of a double-edged sword. When you have a beautiful building, a famous building, you've got beautiful building and famous building problems as well. So here are the shop drawings. Again, we're going back to the grid. You can see again, this is the west facade, all the floors. And then when you break down the shop drawings, you can see just how many individual stones. Everything that is shaded is a stone that needed to be replaced. There's no pattern to it. Some floors are much better than others, and we have to go grid by grid. Now, how is that done exactly? So as much as the contractor would love to just take a jackhammer to this and get this going, he can't. We need these stones. We need these stones because we need to replicate them exactly, with not only just the face, but also the backup, the webbing, the depth, all of that. So they are carefully taken out piece by piece so that they can be measured and sent to California to then have a mold done. And I'll get into that later. But the stones themselves, while they do have the steel support system, they also do support each other up and down with live loads and side to side with lateral loads. So we can't just remove them and call it a day. We have to then shore carefully the stones above so we're not causing further damage by replacing one stone. In addition, as I mentioned before, this building has no waterproofing. These buildings, very common in the era, it was called a bonded masonry building, where basically the architects and developers and contractors would build a wall thick enough with the hope that any moisture or rain that came in would eventually evaporate before it made its way into the interior spaces. And by removing the terracotta, we have completely removed the main obstacle for water coming into the facade. We don't want to make the building any worse by doing this project, so we have to then waterproof with peel and stick membrane. And that is done, again, at every location of the 3,200 stones we've taken out. Here's our field office. You can see some shop drawings. That's one of the lines heads there. There's some materials. Because it's converting to residences, I like to think that this is probably the last office that the Flatiron Building will have, which is a little bit bittersweet, but it's quite the honor. Here are the shop drawings. You can see just the vast variety of styles, types, sizes of stones. These are kind of more flat fascia pieces. Then we have some at the columns. Some are very ornamental. Some are very decorative. Some are not exactly 90-degree pieces either. We've got some radial columns, some concave, convex pieces, water tables. rosette stones, sills, lintels, etc. It just continues. Every inch of this building has something a little bit different, and each one has to be matched exactly. So once we have all these shop drawings, the vendor then creates a plaster mold so that the clay can be hand pressed. You can see a mold here on the right, and it's hand pressed into the sides of as the walls and interior webs are formed. More simpler pieces can be extruded through a die or a mold, but regardless if it's pressed or extruded, it's still dried with hot air. It's then glazed, and it's placed in a kiln for burning. Temperature gets slowly raised between 500 and 900 degrees Celsius, and that whole process can take up to 2 weeks. Once the stones are cured, they then follow a QA/QC process to make sure they meet ASTM specifications and standards. And then the big issue is that due to industry backlogs, high demand and short supply, it can take 8 to 18 months to receive a single unit from when we first call it out for replacement. This is a major problem within New York City and elsewhere, and it's all because there's just 2 vendors left, and the lead times are extensive. And if you go with substitute materials such as precast, fiberglass, or even GFRC, you can get that locally, and we're talking a matter of weeks versus months. So, but unfortunately, with the Flatiron Building, as before, we have to go with terracotta. So while that's all going on, we are still working. We're still doing architecture and engineering. The primary focus at this point is we're taking out the stones. How do we put them back in? How do we make sure that they are fully supported? We're not going to use the original iron straps that have all rusted out. We have to come up with modern technology. And that is most commonly stainless steel threaded rods that are put in epoxy or non-street grout. And then we do pull tests. You can see the machine here, which is 575 pounds per linear foot on one anchor. And these stones will have multiple anchors. So we do that all to make sure that the factor of safety is covered. We're also working with the vendor and landmarks to make sure that we are matching the stone as best we can. It's very difficult to match existing facades. I'm sure if you walk through the city, you can see where repairs have been done. The harsh reality is that even if you found the exact same stone from the exact same supplier, that stone hasn't been sitting outside in New York City for 120 years. So it'll be aged in its own way. But we do the best we can. We look at direct sunlight, indirect sunlight, shade, etc. Try to match the texture, any of the aggregate speckles as well. So as these stones are made, they are shipped back to Flatiron Building. The Flatiron Building has been vacant since McMillan left in 2019. Plenty of space for us to store all of these stones. They are not outside. They're not in anyone's way. They're not going to get snowed on. Plenty of space. They're all individually marked and tagged, and they sit there and wait to be put back in. And that is done by hand, each individual stone. While the stones are heavy, they are still made out of clay, right? So if you rest them on the side, they will fall. If you drop them, they will break. Men have to be very careful as they insert them. And you can see this one stone requires, it's actually 5 workers, 4 workers, and a foreman in the back watching. So you can understand just the extensive process it takes to work on a facade like this. So I'll show you some samples of stones that have already been put in. This is a collar joint at the columns about the terrace on 19. You can see patches were done in the past, and we thought it'd be better just to replace them entirely. You can see this is the original here on the left. You can see it's been repaired before, 2 cracks on the upper corners, another crack spanning between the two. And this is the replacement piece. And you can see just the level of ornamentation and detail that has to be matched. So it's a very, very good match. At the water tables, the concave and convex elements are also installed and matched. And, again, at lower levels, you've got some ornamental sides and some more flat fascia sides. You can see pieces here on angles. The building has everything. It just continues to have ornamentation. It has medallions. It has rope bands, rosettes, lots and lots of things that I had to go to my old architecture books to find the terminology for. The Flatiron Building has it. Here's the lion's head. The one that was taken out was in the field office. That's the one that has been installed. And again, this is terracotta going back in a terracotta building. You have a kind of coat of arms here at the terrace as well. I think it's very fascinating. Okay, And I like to end this with just a case study. Anyone that's a little bit more technical will probably really greatly appreciate this, but we're going to be talking about the cornice. Cornice is also known as the crown. It's the very top of the building, acts as the hat of the building. You can see there's an inspector right there inspecting the cornice. And for the Flatiron Building, we have a cornice that's made out of 9 individual molds, 2,500 stones, which start at the coping stone here up at the top and work its way down to the dentils here. All told, it's 6 feet tall. It's 467 feet wide. Again, it goes around all the facades of the building. And it cantilevers 4 feet out, and it's 275 feet above the sidewalk in public. Previous stitching repairs were done nearly 30 years ago. You can actually see that in the photograph here. But given the cornice's prominence and the fact that it's projecting out and it's so high up, we wanted to take another look at it. And we started to do sounding from our rope inspections. You can actually see an inspector doing it in this photograph. And we did not like what we heard once we hit the stone with a hammer. So we decided once we had the pipe scaffolding in place that we could take out a few stones and start some of these probes and find out exactly what's going on. So here is one stone that has been taken out, and you can see this 2x4 shoring is going down to the platform that the photographer is standing on. And you have the stitch repair, and a stitch repair is merely, it's a crack repair where they add additional threaded rods in the facade. It's like a human wound, right? You get stitches. For a building wound, you can also do stitches. They are great, they are common, but the caveat is that they're only as good as deep as you cut. And you can see here that the crack continues all the way through the stone to the back angle, which I will highlight on the next slide. This is a full depth crack, and it is one of the worst things you can find on a terracotta building. And the reason for this in particular is that, again, this stone is supported by the steel and iron members. And those steel and iron members is the angle up here and the steel strap here. And this crack, rather inconveniently, bypasses both of them. So in effect, we have a stone this big resting only on this tiny little lip here and being held in place with the old 30-year-old stitches and the stones on either side. So a little bit too much of friction being utilized here, and certainly something that we were not comfortable with, nor was our client. So the decision was made as we continued to probe elsewhere. We kept finding the same condition over and over again, that we understood that the repairs lasted 30 years, but aren't going to last another. So we have to then take them all out. So that is these stones here. It's 268 individual stones that need to be taken out without disturbing the remaining 2,232 stones within the cornice. So how that was done was tasked with AWR. And then we had to then flesh out the logistics of reinstallation with the new terracotta pieces on a grand scale. So the first step is to take them out without causing instability for the stones above. We started to do a little bit of a pilot program with some steel members, some angles. The assembly has this very large steel support system behind it, which thankfully was in very good shape. So we decided it's there, let's utilize it. So we started to come up with some steel angles. You can see we did it vertically, horizontally. The vertical one was great because it supported the stone. The horizontal one misses it, but it has a better anchor point. So we ended up coming with a hybrid, which is this piece that's on a 45-degree angle. It's made out of 1/4 inch and 3/8 inch steel plates, and it's welded to the system. And effectively, men take out the stone, they install one, men take out the next stone, they all install one, and it continues down all the joints. You can see here. So the system was great. The work has continued around all 3 facades, just taking out stone bit by bit and installing these new 45-degree angle braces, which supported the rest of the cornice directly above. So now that we have the stones out and they're being manufactured, we have to figure out how to put them back in, right? Again, we're not going to use those old iron straps that have rusted and caused all the problems. We need to come up with new modern ways. And one of the ways we first proposed was, well, we have these 45-degree straps that we just spent all this client's time and money on and engineering on. Why don't we reutilize them for the new stones? Why don't we install a new steel piece, vertical piece that's welded, drops down, and creates some type of anchorage with the stones? And one of our first ideas was, we'll create holes in the stones and run very large threaded rods through the stones. And they'll effectively hang on those and be part of the overall steel system behind. And so we got two in, which we were happy about, but then we immediately ran into problems. The first one, which is a little bit obvious, is that the Flatiron has curved corners, not nice dead straight corners, and long threaded rods are not going to bend or curve. Secondly, every stone that comes back is slightly different on terms of its sizing. And so it doesn't give us any tolerance or play when we try to put in the threaded rods, because the threaded rods are the same size, but the holes in their locations might just be fractions of an inch up or down or left or right, and that is going to be a major problem. Lastly, this steel plate, while it's super strong and it was a great addition, the original stones never had anything like this in between at the joint. And so unfortunately, this steel plate is simply just too thick for the cornerstones. So we had to scrap the idea of the steel plate, vertical steel plate entirely, and come up with a different idea. So our next idea is ignore the steel plate, ignore the brace. Let's go back to the steel structure that's behind that, the original steel structure of the cornice. Let's install new rods that act as hooks that we can then come up with smaller threaded rods, 8 inches wide, that give a lot more tolerance and play for the installation. They can be slightly adjusted here and there, and we're not worried about a continuous band. Those hooks are then welded to the rods, which sit in non-shrink grout and are individually placed as the men continue to put the new stones back. And you can see here's one of the first mock-ups we came up with, which again, here is the new brace. Here are the threaded rod hooks with the bars, goes in, and it's also within the reveal here. So there's plenty of space. We don't have, originally the plate was over on this side, it's on the lip, and that was part of the problem. Here we have plenty of space. We can fill that in. Not a problem. Excellent. Very happy about that. So once we started to get the new stones back, however, we ran into another problem. These stones are not put in dead on. The men have to come in at an angle because they need to engage the bars. So if you imagine, if you put it in, you've got these bars poking out, it's not going to fit. You have to come in from the side and kind of slide it in and then continue to work your way in. So the brace that was originally there is now in the way. So they have to take one of them out to get the stone in and install this. The issue we found out, though, is now that we're putting the brace back, we only have access to the right side of the brace in this photograph. We don't have access to both sides, which means half the welds, which roughly means half the strength. And unfortunately, that wasn't enough. So now we have to come up with a new brace system, which can work with welds only be accessible on one side. And then you can also see just the difficulty. Again, there's 4 men in this photograph installing this very heavy stone. It's above eye level. It's a very laborious, very difficult process. So working with the structural engineers, we got rid of the 45. We came up actually with the dead 90. It's kind of similar to the original idea of dropping the vertical plate. Now we're actually putting it back here. Basically allows us a lot more points of contact for the welds. It's a stronger connection. And with that, we're able to then continue to install and put the stones in. And the stones have been going in continuously. Again, it's 265 stones. I think roughly we have probably half of them in already. And to me, they look great. These are all brand new stones amidst the cornice. Now, lastly, that's not the only stone of the cornice. We have other stones below it. We have those rosette stones. There was a shop drawing of that earlier. We have these very large stones that we call as planter boxes. We have these infill stones in between. Those planter boxes are supported by an eye bolt and a rod system. They have straps in between them. It's very complicated, and I would gladly get into the details of how those are installed, but unfortunately, that's all the time we have for today. So I'd like to thank everybody for listening and would happy to answer any questions.
Thank you. Does anyone have any questions? You can put them in the chat. One question is, so how do you prevent this same thing from happening again? Are the steel structures now waterproof, or are they prepared in a different way?
Yes. So any steel that remains that is still in good shape, which is very common that the steel, even if it's rusted, can still be salvaged. It's scrape prime and painted. It's then waterproof with modern materials. And then the key thing is that the new anchors that go back in are stainless steel, right, which is an alloy, which does not rust nearly as much as regular iron or steel would. So, the goal is if you waterproof and you put in far more stronger rust prohibitive materials, you will get a much longer life out of the facade.
Hannah, I think you had a question, but I'm not sure what, I don't think you finished writing. You may also unmute yourself if you prefer to just ask the question out loud. Until she does that. So I don't know if you had mentioned how long did this entire thing take?
So it first started at the end of 2018, and construction started 2019, right as COVID ran in. We were able to continue it going. It was considered an essential service, but that certainly slowed everything down, supply chains, et cetera. So it's been going on for quite a while. It's not 2025.
And when do you think it'll be finished?
Excellent question. Would love to answer that. I would love to be finished with this building by the end of the year.
And I wanted to just ask, at least one of the stones that was installed that was new had a chip on it. Um, was that typical of the new blocks, or is just an unusual situation?
It again, the stones are fragile, and sometimes in shipping or just getting off the truck, they do get chips. We do have a product that the vendor supplies, which reglazes the small little chip that protects the viscous.
Can you say what that product is?
It's typically a potassium silica coating, though I don't know specifically the one that Gladdy McBean, uh, the name of their product, but that's usually the material.
Thanks.
Mhm.
Someone asked if there were continuing ed credits for this class. Yes, there are. You can email me, marbulu@hdc.org with your AIA number if you would like credit.
Can you say what condition the faces were in? There are some wonderful circular faces.
Right, they have some cherubs. I think for the most part, those cherub faces, the baby faces, are actually in pretty good shape, thankfully.
They don't look like cherubs. They look like very sad women. The big round, they're just heads. Yeah,
Yeah,
great. I'm
those
glad
in
to
the
hear
fingers.
that.
Yeah. Mhm.
Someone asked why you went with the California Terracotta Company instead of Boston Valley, which is in New York State.
Very good question. The answer is they gave a better price.
Fair enough. A follow-up question to that, what was the budget? Or what is the budget?
It's around $10 million for the facade.
Also, I think Boston Valley is doing a lot more extruded work and new work, yet Gladdy McBean is only doing um, restoration work. They're primarily not involved in new design, new construction.
I've certainly worked with both. Again, there's only two companies, so you have to work with both.
Had you contacted the English company?
I've heard of that company. I know they have started to get established. We haven't yet engaged in any projects yet, but I certainly would love more competition
Yes, it would be
and
good.
new plants, please. That would make my life and my client's life a lot easier.
Hannah then asked, how does the restoration affect the overall structure of the building?
Great question. The answer is it shouldn't. We're going back with similar materials. We're going back with basically the goal is to not affect the structure whatsoever. That is a concern if you're going with replacement materials precast and GFRC are commonly 3 to 5 times heavier than terracotta. So if you're replacing a lot of terracotta with architectural precast, which is effectively concrete, you do have to take into consideration the structure of the building. You also have to watch out with a major issue is if you take a precast piece and you put it above a terracotta piece, that precast piece can crush the terracotta piece below. Very counterintuitive. So you have to come up with other ways that individual precast piece can be structurally supported without negatively affecting the stones around it. But for this one, because we're going back with the same material, we have no effect on the overall structure.
And someone asks, were there any historic restoration tax benefits obtained?
I can't answer that, only because I wasn't involved in any type of financing for the project. We only filed it with DOB and LPC.
Were the terracotta pieces glazed at all?
Yes.
Is it just like a clear coat?
There's a lot of different types. It really depends on the aesthetics of the stone and kind of there's a vast variety. But we were just matching the original, which does have a glaze, but it's not as dramatic as there are plenty of buildings in New York City where you can see blues and greens and reds. And that's, you know, a difference. They use a lot more pigments.
This glaze was much closer to being a slip, which is liquid clay, having very little glass in it. So it doesn't have any gloss at all.
Right. Yeah, it reads a lot more flatter, a lot more of a matte.
Are there any other questions?
The statue of a monster.
Good presentation.
Thank you, Susan. And thank you for your questions and your insight.
HCC did give Susan Tunick, Gladys McBean, and Boston Valley all a lion, our Landmarks Lion 1 year for their terracotta work. How do you obtain a copy of this recording? Great question. It will be available on our YouTube channel as well as our website. It'll probably be up in the next 2 weeks. You can also check out our YouTube channel for all of our other preservation school classes and lots of other virtual tours, presentations, lots of other content. Please do check out. There's a lot there. So not seeing any other questions, I think we are good. Thank you very much, everyone, for joining today. As I mentioned, we have 2 other preservation school classes scheduled for the month, so check out our website, hdc.org. Thank you so much, Alexei. This was fantastic. We were planning this for a while. This was great.
Thank you, Michelle. Greatly appreciate it.
And yes, have a good day, everyone.
Okay. Thank you, everybody.